I'm Will Lennox from Channel 9, which is a free-to-air broadcaster based nationally in Australia, but specifically I'm based in Sydney. My job is to make sure we can get all vision, audio and ancillary data around the facility. So because we're an IP 2110 facility, a lot of traditional devices still use SDI, so we have to be able to sort of bridge between SDI, 2110 and NDI. So we use the Bird Dog Studios and the Bird Dog Quad 4Ks to make sure that we can get SDI into NDI and vice versa, and that'll all go into our 2110 conversion devices. So to be able to get into software that's NDI based, the Quad 4Ks are definitely the go-to devices for us within the NDI environment. In the city, in North Sydney specifically, you have very specific ratings that are required for anything on the roof. In our tower, our mounting for wind speeds and whether IP67 rated, the Bird Dog A300 met those requirements. We also had a requirement for redundancy, so we have the SDI as well as the NDI out, in which we have a PoE injector that goes into the switch. If we ever lose any of that networking infrastructure, we have the SDI going into a fiber converter, which goes all the way down into the data center, so we can make sure we're always getting that footage if required. That footage is also recorded 24/7, 365 into one of our EBSs. So if anything ever happens, we can make sure we can shuttle through that, and that's available to us. The wide shot of Sydney Harbour is probably the most important for us and for news downstairs. They use that in the backdrop of the 1600 news. It's also used for car accidents on the bridge, any events that happen in the harbour that we can zoom in on. The great zoom that the camera has allows us to get pretty good shots of any accidents or events like that at the Opera House or anywhere along the harbour there. Back to weather, we also look at the sort of rolling storms that can come in from out east in the ocean or from the west over the hills. We get awesome weather shots coming in from that, and they love the time-lapse shots, and they use those in combination with storm footage. They get some pretty cool shots. Being able to access all the devices within the same network and just select source and destinations is one of the main attractions for us. We can push that back onto our producers and our operators in small control rooms and controlled environments, and it just makes it a lot easier.
Well, it is that time again, everybody. Hope you are doing well. My name is Bird Dog John, and I am back in action.
In those scenarios, it's good to neuralize the cameras. You guys know that best.
Very straightforward. Plug it in, go to the web UI, link the source, walk away. Like super simple. I keep looking over at the chat, and I keep seeing you are full of it. Tasty, spicy meat snacks. Covered in flavor. I mean, you can't go wrong. So what's going on? We've got a handful of folks here in the chat, and I really appreciate that. What's up, mate? Hey, Warren, how are you? Appreciate it. Hey, Robbie, how's it going, man? We were just talking about you. What's going on, Tom? Ahoy. How is it going? What's going on, Go Web? Good to see you again. Thanks for hanging out with us again today. Appreciate that. Feel like I'm in this video more than anyone but John. It's true, NetApp. You are, I'm going to cut this up and put this in the next intro. Hey, what's going on, everybody? Whoa. I'm hearing double. Hopefully you're doing well. Thanks for stopping on by. Welcome to the Bird Dog Live show. Let's fix this doubling issue. So I hate that vMix, every time you make a change, you have to restart the program. Like, what are you, a Windows-based program? For crying out loud. It's a doozy. So super annoying, but I've been trying to sort out the audio issue that I'm having where last time I was hearing double of myself, like anytime I talk, it was feeding it back through. It was doing like a headphone loop. And in the past, I was able to just hear basically the program, the videos, all of that stuff, but not hear double on my microphone. Well, that's all well and good. I'm going to tighten this up here. That's all well and good, except I don't want to hear the microphone. So I turned that off, and then I restarted vMix, and then I rushed in here today, and lo and behold, now I can't hear any of the videos or any of the music or anything like that. So that's also kind of annoying, which means that I'm actually not listening to the show live. So that sounds pretty good. You guys let me know what the audio sounds like. I'm just watching it on my phone, and I'll let that run for a little bit. So that was quite the exercise to get everything set up here this morning, and I had a remote session with a client across the pond, and now I am done with that and trying to get ready for the show. And as you can see in the topic, it is not just it's not just a simple one. So we're going to try and be somewhat helpful here today. We want to talk about NDI and subnetting. Uh-oh. What is going on there? Oh, wrong camera selected. Okay. It was supposed to be okay, playlist. You suck. All right, let's change the playlist real quick. So change it. I'm constantly changing the cameras, and so it's my own stupid fault for doing that. But here we go. Let's go ahead and begin it selected. So this was the shot that I was trying to get to. Is it out of focus? This shot looks out of focus. Is it maybe low bandwidth? It is low bandwidth. That's why. Boom. So there. I was having issues. So that camera's over here now. This is the 110. I was having issues with that camera because what I ended up finding out was the bandwidth coming into my computer. So I was having an issue with the fiber cables, and I had messed up the lines going into. I'd messed up the fiber connections. I have dual fiber connections into my vMix machine, so I had messed up those, and one of them was working, one of them wasn't. Well, I'm bringing in a ton of NDI stuff across the wire, and so this computer is not good with just 1 gig connection. And this is a great lesson for you, by the way. Doesn't matter whether you're in the HX camp or you're in the full NDI camp. Doesn't really matter. You need some bandwidth to really play with high performance video. And 1 gig for 1 or 2 cameras is fine, but if you start doing multiples, and I've got Auburn Road, I've got an overhead camera, which does not appear to be working, actually. I've got an overhead camera. Where is that overhead camera? What is going on here this morning? I am so confused. That camera is here. Okay, so it's working there, but it's not working in the multi-viewer. Okay, good to know. So, I've got overhead, I've got Auburn Road, I've got the P110, I've got the P4K. I used to have a P200, which is currently sitting there, but it's not plugged in right now. And then I've got vMix is outputting an NDI signal. I've got multi-viewer that's coming across the wire, which I'm not actually using on this vMix machine. VLC is generating an NDI audio channel. What else do I got? Anyways, there's a lot of NDI stuff going on here. And I should also turn on my audio... Yoink, my audio meter from Zen, the Zen No Audio meter, just to make sure that since I'm not monitoring my audio in real time, it'll tell me if it's not working on that NDI output. All right, let me jump over to the chat real quick. What's going on, Angus? Hopefully you're doing well. Thanks for stopping by. Always good to see you out there in Western Canada. Cool times. I've been following loosely the mayoral race in Toronto, or as we normally say at home, Toronto. But I'm following that, just curious. There's like over 100 candidates for the mayor thing in Toronto. There's like 8 serious ones, but then there's all these other people that put their name in the hat, so that's funny. My friend from Stockholm, Sweden, what's going on? Hopefully you're doing well. Thank you for tuning in today. Something's up with my lighting. It just seems dark to me. It seems like that front light is not bright enough, but it is. But it may be the P4K, because this secondary shot doesn't look too bad, but it just seems maybe the P4K, the iris is closed a little bit. I might alter that in a minute, but let me get through the chat. Good morning from Vancouver Island. Oh, you're on Vancouver Island? I was on last year. I went to Victoria. And that was the first time I had gotten out to BC, and it was gorgeous. And jealous that you also are out that way. Hopefully you're doing well. Thanks for stopping by, Laura. Wow, you're on my first day of a new install. Are you doing an install project out there, or are you living out there? Or what's the story there? Good morning from NYC. What's going on, transmission? Hey, good morning, Bird Dog John. Looks good. Sounds good. Excellent, Mike. Thank you for the thanks for the help here. No one No one here but us subnets. What's going on, NetApp? Rizzo, morning from Wisconsin. Good morning. Thanks for checking in. I don't recognize your username, so if you're relatively new, welcome, welcome. If not, my apologies. If you've been around for a while. Good morning from Texas. What's going on, Pandorica? Tuning into the show down there in Texas. Appreciate that. It's a little early for you, isn't it? I guess it's mid-morning for you at this point. Hey, I ran my first live production this weekend with my NDI audio stage box with great success. It is a USB interface connected to a laptop that runs NDI free audio from the SDK. Right on. I would love to know more about that throwdown box. Some of the technical details would be very useful to find out that information. I'm living here. We're installing our new TriCaster, more bird dogs today and tomorrow. Excellent. Of course, reach out to us if you have any issues between now and Thursday at help@birddog.tv. But yeah, that's awesome. And of course, Laura, you can hit us up here. It's always good to chat about what you're up to. Now, we had talked about, I should do this. How can I bring this in? So, Laura, I did a studio tour when I changed things around here the other day, right? And Laura said, you've inspired me to change some stuff around. And so she did kind of a studio update / tour / before they change a bunch of stuff. Let me see if I can pull that up. I did save the post, but let me see if I can quickly grab this and share this on a screen. Scroll down. I get so many notifications. It's crazy. Come on. There we go. Keep going. Come on. Well, for crying out loud. For crying out loud. Let's go. I think he posted this on the bird. There it is. You mentioned me in a comment. Okay, so I'm going to put this up on my secondary screen, which is over here. And we're going to turn off the playlist real quick. Screen capture. That's another thing that I'm running that's bringing NDI into this. And when we talk about subnets, I need to write some stuff to help explain it. So I'm going to try and bring in over a Flex my iPad screen. So we're going to give that a go. So much stuff going on. Okay. Whoa, that's super loud. How am I going to bring the audio in? Before we upgrade, it says, do I have in vMix the desktop audio? I think I do. Where is the desktop? I'm sorting this all out here kind of on the fly, folks, so bear with me. Desktop, here it is. So if I play this, do you hear this? There's no audio in that channel. Let's put this here. And let's change. Close. Let's change. Where are we here? Crap. Does it not show? Bear with me, folks. Bear with me. Nope, it's not showing on the meters. Dang it. Okay, well, let's try something else. Or did you hear that by any chance? Okay, well, hang on, I gotta test that. I don't think you would have heard that. How can I do this? I know why. Inside screen capture, I need to specify what is my audio source, right? So let's say system audio. This is dangerous. Let's try this again. Hey, there it is. Okay, cool. All right, let's switch over now to this screen. Can I make this even more full screen? Yes, I can. All right, so here we go. Fade over to that, and hopefully we can all hear this together. So let's give this a go. This is from Laura, who's right here on the show. running a wing. Those are pretty nice. $240. Hey, that's well done. Good for you. That was pretty cool. I love that sort of stuff, man. It's just easy peasy, you know. Just put that together. Okay, I'm going to kill the desktop audio because who knows what's going to happen next. Cancel. Really cool. Thanks for sharing that, Laura. And I did ask permission to show it, by the way, so it's want to be sure that was clear. It's good stuff. I really appreciate that. It does. It's so cool. Like, I mean, we spend a lot of time, you know, servicing products and talking to customers through issues and whatever that they're having. But trade shows, videos like that, like showing what it is that you guys are up to out there with the products, and then actually generating content for people. It's really cool. So it's great to see that stuff, and it always helps us kind of ground a little bit as to this is what people do with our gear, and they kind of make things happen. So really cool. Good afternoon from Belgium. What's going on? I would call you Facebook user, but I can do you one better and actually call you by your name, Oliver. So what's going on? Hopefully you're doing well over there in Belgium. Hey, it looks like a great place to work. I would agree, Angus. It does look like a great place to work out there in beautiful Vancouver Island. So what an awesome opportunity. And you've got more cameras going in. So tell us a little bit about that, Laura. Yes, well done. Very well done. Today I do not have snacks on stream because I do want to allocate time to do the subnet thing, hopefully some level of justice. But I'm just one guy, and so hopefully you'll be able to share in your experiences with subnetting. I know this sounds riveting, like riveting content. But we do want to talk about it because actually it's one of those things that some people just don't know. They just don't know, and this is a great venue to talk through some of that. So we are going to talk about that. But I don't have snacks on stream, but I do have water, and I do have an Ember mug full of coffee made with lots of love and care from Bird Dog Brayton. So I've got coffee here and the Ember mug. I'm going to drink it first because it's currently actually hot, and the mug is keeping it hot. So we're gonna do that while we talk a little bit and share. Oh, whoops! And I need to. What am I doing here? I need to close down this Chrome browser because it's chewing up bandwidth. Yoink. Okay. Closed. Now the P4K is a little dim, and so I'm going to brighten that up. We're going to take a quick little look at the iris settings and just see what we're at. Okay, so we're full open right now. So if we introduce 3 more decibels of light, and that's of gain basically, which is the worst case scenario, it looks pretty good though. I am lounging in this chair a bit. I might lower it and then adjust in Studio Monitor this shot because I don't particularly, my knees are hitting the table, and that's going to hurt after at least another 40 minutes of this exciting. So let's adjust this slightly. You can see my water bottle. I'll move that out of the shot. All right, that's a little better. I think I like that where it is. Okay. So we're good to go there, and I'm going to jump back over to the chat just to make sure I haven't forgotten anybody. There's a whole bunch of you guys over here, and if you're hanging out with us over on LinkedIn, I actually don't know if you're there. So give us a shout out in the chat if you're on LinkedIn, because StreamYard doesn't tell me if you're watching on LinkedIn. It only allows basically a one-way street over to the platform, and so I'm not able to actually see if you're attending. So if you're on LinkedIn, thank you very much for joining us over there. By all means, hang out. But, let me know you're there, because I don't know how many people are over there. But there are a bunch of devices checked in right here on YouTube and Facebook and Twitch. So good times. And the main place, of course, as everybody knows, is at birddogjohn.tv. That is kind of the main hub for all of this support show. I had an opportunity last night to talk to some of the executives about this show and what it is that we're doing over here. And from a business standpoint, it's a challenge to put down on paper what the metric is, like a value, right? So it is an interesting conversation to have. But me personally, I think that this is a great opportunity for people just to interact with us, but also ask their questions and to learn a little bit, and to create a hub where people can go and learn about the products and about how it works and how you get it working on your network and all of that sort of good stuff. So each show, I do so many of these, and so each show we get to talk about small incremental things, and over time that adds up to a fair bit of information, right? So that's what we're going to do here. I'm doing more and more of that, but basically subnets, that's like one piece of the greater conversation about getting this stuff to work, and yeah, that's what we're up to. So here we go. I also have upgraded before we get into subnets, I've also have upgraded the TV in which the multi-viewer is on. And it is now a 55-inch TV. Is this 50 inches, 55 inches? It's a 55-inch TV. The issue is that I'm running multi-viewer on a computer in the office that's supplying multi-viewer to multiple places, and a multi-viewer Pro, and that's coming here. But if I look at my image, like I've put my P4K pretty much right in front of the P4K image on the multi-viewer. But if I look at that image and I look at my face, you can totally see my eyes are not looking at the lens. And so, man, I'm fighting the temptation to look at my actual picture, but to look anywhere other than the actual lens. So that's my goal. If you see my eyes drift, that is probably because I'm looking at other cameras. But anyways, we're learning. I don't do this professionally. I'm just a guy with a microphone. So that is that's one of the trade-offs. It's one of the joys. We're real people over here, folks. That's for sure. MTash says, good morning from LA. What's going on? Thanks for joining us today, MTash. Always nice to see you. I installed this in a rack case, an HP. So we were talking about the NDI audio, the part of the SDK that my friend from Stockholm here has created, basically an NDI audio throwdown box. So he's got an HP i5 laptop running 5 instances of the NDI free audio connected to a Behringer UMC 1820 USB interface. I know that interface. I have that interface at home. That's a great little interface. Great USB interface. For the money too, by the way. It's a steal. Also in the case is my wireless receivers with DI boxes and a network switch. What are you running for a network switch? Or do you prefer not to say? Hey, thanks. Yeah, we have 4 or more P240s coming and a 4K. Also not shown there, we've also got 2 flexes, another P200 above the stage. New TriCaster Elite 2 is coming. Streaming has helped out our little theater. That's amazing. I love that. I am so pleased to hear that Bird Dog is a part of that story. And if I ever get out to BC and Vancouver Island, I will be making a phone call because I want to come and see that. That looks so cool. The show provides the one thing most companies don't provide, the human interaction, both visual and verbal and informative. Oh, MTash? Man, that is so stinking kind of you. Thank you for saying that. That is the goal, right? The goal and this is one of the things I actually said to the ELT. I said, I actually don't know of another company that does what we do on this show, that actually provides, and it's a bit of a wild card. I mean, for owners, it might make them a little nervous because, like, who knows what John's going to say. But the plus side is that people actually want to have an interactive platform where they can talk and be heard, and somebody in the company will think about what it is they're saying and get back to them with real information, right? So I get it. I definitely understand. Because I want this in so many of the companies that I use their products. For example, that little microphone that I have, right? That's like the binaural microphone from 3DO. They're a microphone company, but they don't do anything like this where they interact with their customers with their microphones. It's bizarre to me. I would love to have that avenue. As a matter of fact, I don't know officially if they do or not, but I've never seen it promoted, and I certainly follow them on social media, but I've never seen it pushed, and that is one of those things. It's like, man, you're a camera company. Use your cameras in a product, in like a little thing every week, you know? A lot of the time, those little companies, though, are just way too busy, and granted, we are too, but I think that this is important enough to make a priority about it. Anyway, there we go. You need a prompter. You are not joking. So Jake did a studio tour, and if you missed it, it is available on my live streams. I chopped out all the show, and I just left Jake's studio tour, but he's using a teleprompter, and he's got a Bird Dog camera in one of them because what was the brand that he was using? He got it on loan from the company, but the little teleprompter, that's what I really want. And I've been flirting with the idea of buying one, but it's really hard for me to justify spending that amount of money on my own money. So I'll have to talk to the CFO. I'm pretty good friends with him. Maybe we could work something out. But anyways, I do want a teleprompter, even just a bad one, because then I could go to a smaller multi-viewer like this and totally be looking at the lens all the time. Doesn't matter where I look. So yes, or I could just use another play, so I could leave this and use another play. Oh man, yeah, I want to do that now. All right. Well, anyways, hey, you're just an unprofessional guy with a professional microphone. Touche. This is the RE20. Don't get me started. I love to talk about this microphone. I love it. That's so good. Hey, I've got a Lenovo laptop that runs Windows 10 with a 7th Gen Core i5. It would be great as an NDI teleprompter. There you go. Tear it up. Let me know. Angus, you've got all sorts of free time out there. So I know you've got all sorts of time just to hang around and invent things, Oliver says, hey, that's indeed one of the added values from Bird Dog, having a close contact with your customers and hearing them. Much appreciated. Continuous improvements relies on strong communication. I would agree with you full-heartedly. I do think that is one of the things that makes a difference. Not only when I go places, go to trade shows, when I represent Bird Dog at places like that, people know me as an employee, but also they know my support department and they know my personality, but also they know kind of our philosophy when it comes to how it is we provide support and how it moves and supports the greater Bird Dog organization and all of that stuff, right? So just having constant contact with you guys and having that interaction where I can pull up your comments and throw them on the screen and talk with you about that stuff, or I can show a studio tour and then Laura goes out and makes a video about her studio or theater, and then we can throw that up and we can watch that together. I mean, all of that. It's adding these pieces to the conversation so that, so we build a small little community around it. So I'm really happy about that. I wish you don't have all the free time you wanted, huh? The switch is a Ubiquiti switch, which is a US XG 6PoE. It's also my aggregator. Yeah, okay, going back to the OB van. Very cool. I mean, that's a pretty good switch for what it is that you need. Have you tried the teleprompter app in Central Control? No, I have not. Okay, let me see if I can pull up let me see if I can pull up this NDI feed that's, I need to add it. Oh, this is always a gamble. Adding inputs mid-show. So this is real time, folks, right here. We're going to add an NDI source. This is a flex. This is a flex. First of all, I guess I need to find out what that source is called. So we're going to open Studio Monitor and take a quick little peek at, where are we here? Oh, it's this one. ADD. All right. This one. So let's see if it brings it in correctly. Is the screen on? Yeah, the screen's on. Is it that one? Wait a minute. I screwed that up. Yoink. Yoink. HDMI. It is not generating any ND. Oh, yes, it is. Oh, it's just a black screen. Oh, cool. That actually worked. Really cool. All right, so let's close that. Let's close Chrome because we all know Chrome is going to chew up your bandwidth. And if I cut over to this, can you see this? Oh, really cool. All right, so that's my iPad. All right, now I just need to add my beautiful face in the corner because, I know what you guys really want is more of me. I know that is the desire in this world is more of John. I know that's what Senseless wants. He just can't get enough of my beautiful presence. It's okay. He's not watching. All right. So if we go and let's just move this image off screen. There we go. And then I'm going to crop some of this shot because, whoops, not that way. Because you don't need to see all of my face. And maybe that's the top. Maybe the bottom? Nope. Man, I'm really screwing this up. Sorry, guys. There we go. Okay. And now I can put this down in the bottom corner. There we go. Okay. So does this work? Can you guys see this all right? I think you can. We'll be all right. Oh, you can't see my hand. All right. All right. So we're going to go ahead and erase this. This is this is the real deal around here. We don't screw around. We do everything live. And that's a part of the joys of coming to watch somebody try and run a show who doesn't have endless amounts of time to set it all up all the time. So I'm going to try to move this microphone so you guys can see a little bit better. Okay. Then I'm going to pull my iPad. I'm going to move my keyboard out of the road. And this is the way that we actually do some of our, I've been doing some classes and whatever. Not classes, but when I do distributor training and whatever, I generally work this way. So I can actually, draw and write and do whatever. Sorry for my chicken scratch. I am going to be writing words here. So you've been warned, but you're here for this, and so am I. So, yoink. Wow, that little HDMI adapter gets warm. Hey, the new studio looks good. Oh, thanks, man. Appreciate that. And how are you doing? Go Web, good to see you. The central control prompter is fantastic. I'll be using it shortly during university. Okay, I'm going to check this out because, and I just realized that your comments are right over my face. See, we learn as we do, folks. We learn as we go. So let's go ahead and move me up to the, let's move me upstairs. Well, hey, guys. That's fun. It's fun that you can kind of do that in real time. All right. So, yoink, let's try that. And I'll try and remember to not write over in the top left-hand corner. Okay. Let's get into this subnetting stuff because we need to. Ooh, and great question, Laura. Hey, how is that Flex interacting with your iPad? So I am coming out of my iPad with a USB-C. This is an iPad Pro 12.9 third generation. USB-C out to HDMI little dongle from Anchor. And then I'm going HDMI into the Flex. The Flex is then receiving that signal. I get a green light on there, and that sends it then into the greater network, which I bring it in over NDI. That's it. That's all I'm doing, and it's doing a screen capture. Now, when you plug in an HDMI device, it actually knows that's what you're probably doing is screen capture. And so it cuts away all of the tools and everything. Like I got highlighters and get whatever in this app. So it cuts away all those tools and it saves you from seeing all that stuff. I can also, it also sends the audio out if I want that for some reason, but it is literally just connected to a dongle, which is right here, and going into the system. So great question. That's how you can do this sort of, a Flex could be running on a lectern, for example. You can plug in the HDMI dongle to your iPad and then show it on the screen if you're using wallplate or whatever. This is real. This is real stuff. This is AV over IP. So good times. Okay, let's talk about subnetting. All right, because we definitely need to have a chat about this and to kind of get a general idea. And I'm going to invite your comments through this, and we'll review those at the end as well. But I want to talk to you a little bit about this because this is a concept in networking that you really probably should have somewhat of an idea as to what's going on and how it interacts with the greater IP world. Now, these particular examples that I'm going to be using, we're talking about something called IPv4. Okay, this is the traditional, 4-octet IP range, and so a typical, let's just say the default, right, for a lot of BirdDog devices, 192.168. Say it with me now, 100.100. You're going to find that IP address on a lot of BirdDog devices as the fallback IP address. And so if you know, if you've interacted with any of our devices in fallback, you know that is the IP address. So we're going to be talking about IPv4. This is not really about IPv6. Some of these concepts translate, but not really. In IPv4, we have the ability to set IPs to certain ranges. And why you would want to do that is there's a greater conversation about how networks work together. Okay? So why would you want to break up a network? Why wouldn't we just have, a single switch and have like a bunch of devices on the network, right? And so we're just going to, create hundreds of devices. And just for demonstration's sake, I'm just going to make a whole bunch here. So we're just going to have a bunch of devices, and we're going to connect these all to this switch. Like, why not just make it all just one big flat and other ones too, going off into greater directions. And we're going to do hundreds of devices, and they're just going to be, like, logically, why doesn't this just work? Why don't we just have a whole bunch of devices and they're all connected to the same switch, and we, just have hundreds and hundreds and hundreds? Well, manageability, really. And the first piece is it's really hard to manage a network that is this big and this unintelligent. And so just from a sake of making your life easy, you want to put some sort of level of intelligence into the network. But the other piece about this is each of these devices, if they're operating correctly, are broadcasting. And so, device whatever number this is, device over here in the corner is going to say, hey, who is so-and-so? Well, if each of these devices is like .1, .2, .3, .4, and so on, right? And .6 wants to find out who number 1 is. It'll say, hey, who's number 1? Well, it's going to send out a broadcast. And that broadcast is going to go throughout the entire network. And every single device that's on this network is going to say, not me, except for this one. Well, if all of these devices are wanting to communicate with various devices on the network, they're going to be all sending out constant broadcasts all the time, wondering who is who, right? And so you're going to get these, who is broadcasts, and generally they're only looking for one of the device on the network. And so if it needs to be this guy, that's great. This guy will say, oh, that's me. But all of these other devices are going to say, not me, not me, not me, not me, not me, not me. And they're all going to be basically flooding the network. In the meantime, these guys are also going to say, hey, who is, so-and-so, and messaging out, and they're also going to be looking for, like, let's say this guy is, .8 or something like that. Hey, where's .8? Well, this broadcast is going to go out, and this guy's going to say, hey, that's me. But then they're also going to have a, hey, not me, not me, not me, not me, not me, not me, and so on and so on. And so you get bottlenecking is what you get. You get this big, it's actually called packet flooding, where you get too many broadcast requests and people cannot process enough. And this poor little $40 switch from Best Buy is not going to be able to keep up with you. So what can we do about this? Can subnetting be a little bit more intelligent? And the answer, of course, is yes. We've logically thought this through. Oh, that's weird. When I run off the screen, it cancels the option. So yes, we can do this a whole lot better. So what we want to do is think about networking in subnets, and there are multiple variations of subnetting in general. We'll get into that a little bit and understand how that's done. But we want to break up our network into manageable bite sizes that we can do this. And so how this is done is typically with what we would traditionally know as a router. Okay, so we're going to put a router on this network, and we're going to then create multiple networks. And in these networks, these are traditionally what we would do is we would put, come on now, we'd put another router here, and we'd connect it like this to a switch. I should use different symbols for different things to make this helpful, but anyway, switches, routers, and so on. And we do the same thing over here and over here. And we would connect all of these together. Okay, switch and switch. And we connect these all together. And then we have devices on each of these networks, right? So they're all connected like this, and same thing here. Now, what's really cool is that all of the devices that are connected to these switches, which are connected to these routers, will all have unique addresses. And that's what an IP address is, right? It's a unique address that is assigned only to one device on a network that is hopefully being controlled by a router. And so we get unique addresses in each of these. So this might be, 10 dot, what is going on here? I hate this. So this might be 10.1, and this might be 10.2, and this might be 10.3. But then over here, this might be, 11.1 and 11.2 and 11.3. All right, so we've got multiple networks. And when a device broadcasts, it actually doesn't go past the router. Okay, the broadcast request doesn't go past the router. But in a computer world, if we need to send data from 10.3 over to 11.2, the broadcast would go out to the router, and the router would know that information, that address is not on my network, and then would send it intelligently through the respective routers and onto the network that it is corresponding. And so it would get to 11.2 through a routing topography, not directly over, over the actual switch with all of the devices plugged in, like I showed in the previous example. So if we are sending a request or information to 11.3, the routers would take over and intelligently route that information over there. So we're going, now, if 10.3 wants to talk to 10.1, over here, then it would send out a broadcast request and would just hit this smaller network, and the information would just travel this way. Okay, but if we're going to 11.2, it needs to then go through these routers and then onto this network and get to the destination through a little bit more advancement. Now, it's really cool because we can create endless amounts of networks in the world and make them all manageable, because we don't all have to be on the same network. As a matter of fact, we can break this down even more, and things can be a lot faster. The broadcast request, for example, if you just have a handful of devices on a network like this, obviously the broadcast requests don't cause flooding, and it keeps things a lot quieter. And we're learning things all over the place about how we do this in NDI. But this is the idea of how IP networks are set up. Now, when we want to start doing subnetting allows us to separate networks in another way, where we can, now, and you've seen subnets that look like this. I'm trying to keep my brain somewhat organized, but bear with me. So you've seen subnets like this, okay? And the question might be, why are they like this? Well, in the computer world, computers speak a different language than these numbers, right? They speak binary, which is ones and zeros. And basically, 1 is open and 0 is closed, to put it overly simplified. Well, binary is worked out in a way through 8. They're called 8 octets. So we're going to create like this. Go down the middle. And we probably need to do one more here somewhere along the way. Let me correct that because that's wildly inaccurate. So, all right. So we got 1, 2, 3, 4, 5, 6, 7, and 8, right? So in here, we have a numbering system. So this is 1, this is 2, this is 4, this is 8, this is 16, this is 32, this is 64, and this is 128. Now, subnets are a way to, I should accurately hear, this is subnet masking. This is an important term. And we'll talk about NDI. We'll go right down to the NDI specifics here, but so that you understand. 255 is all of these numbers added together. All right, so it's 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. It equals 255. But in binary, what that means is there are 8 little there are 8 what's the phrase? It just left me. 8 bits. There we go. There are 8 bits in each of these in each of these octets. So we have 8 spots. And if the spot is consumed, then we have a 1 in that location. And so for 255, okay, we've got 8 spots. 255 means every single one is basically valid or yes. And so that means we have a 1, 1, 1, 1, 1, 1, 1, 1. Okay? That is, in binary, the actual what the octet looks like in ones and zeros. Because each of these, let me change my color here, each of these is used. Okay? So we have we're using 128, we're using 64, we're using 32, we're using 16, we're using 8, we're using 4, 2, and 1 to get 255, which means that every single bit is a 1. So 255, 255, 255.0 in binary looks like this. Whoops, I'm using green. Sorry. Let's change that. Like this. Because 0 is obviously none of those bits are being used during this. When a computer gets an IP address, when it looks at the subnet mask, anything that is a 1 is considered a part of the subnet, is not a part of the addressing system that IPs used. And so when we say using a single subnet that is 22255, what we're saying is the way the computer is reading the network data should only be using the last octet to distinguish devices on the network. And so all the devices on the network, for example, all have the same first 3 octets, so 192.168.1. Those are all the same across the entire subnet, but the last digit is the identifier of the actual device. And so this front portion is the network identifier, and this back portion is the actual device identifier in this particular scenario. Now, we can make this a whole lot more complicated by starting to change numbers. But so that you understand how computers are reading this, 255, 255, 255.0, the binary looks like this. This is what the computer is seeing when it comes into the subnet mask. When it comes into the computer or it comes into the device, this is what it's expecting and how it differentiates between who is who on the network. Now, you can change this number to be something else. For example, you can change this third octet to be 224. So what do we have to add together to get 224? Well, we can do this in real time. Let me pull this up here. Oops. So we can do 128 plus 64 plus 32. That gives us 224. So instead of, let me try and get a smaller eraser here. So instead of all of these bits being used, okay, we're going to take the green off of these. I should have made this easier to do. We're using 128, 165, I'm sorry, 128, 64, and 32 to do this, which means that in binary, this looks like 255, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then we're using the first three, 1, 2, 3, and then 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So that means that the first two octets and these 3 bits are going to be the network identifier, and then the rest will be the device identifier. Okay, so we can increase the number of devices we have on our subnet by the way that our network is working by changing this to 224. Now this works really well with computers, especially if you have a bigger network or maybe you have a wireless network where you have guests coming and going all the time, and you need more than 254 logical addresses on your network. But it doesn't work great when you're trying to do network nodes. Okay, when you're trying to control devices inside of a network and these are nodes on the network, you need to standardize the way that you're doing network IP addressing, which is why you may have seen our network rules where we say, please use a 255, 255, 255, 255 addressing system. Basically, that means that this is the network identifier right here, right? This last one. This is the this is the device identifier. And the network identifier is going to be this number. The way that the NDI protocol seems to be written is in this configuration. Now, there are ways to create additional subnets within a router so that you can have certain floors of departments on certain subnets and that sort of thing. And NDI actually has it written into Access Manager to allow for that variation. But if you're sticking to the actual network topography that is assumed with NDI, and now we're going to kind of get into the NDI discussion. If I've glazed over some portion of the subnet that you are super confused about, please say so in the chat. But NDI is, in general, built on this idea that you're going to use a 22255 NDI network structure, which means that the first 3 portions of the IP address are going to be the same, and that the last digit is going to be the identifier of the device. Now this is kind of fundamentally worked into whether you're going to use DHCP or static. It doesn't really matter which protocol you're planning on using. This seems to be a fundamental part of the base structure of the NDI protocol. Now, to be fair, this may not be intentional. This may just be the way that they designed it all those years ago, and it just continues to operate on that assumption. So you may say, well, why do I have to only be restricted to 254 IP addresses? Well, you aren't necessarily. We can talk about making this more sophisticated, but if you're going to have 254 devices on your NDI network, we're probably not talking about TCP anyways. We're probably talking about multicast, which is a different animal in and of itself and does network addressing differently. And so if you're switching over to multicast because you've got 100 devices, well, some of this stuff is not really super relevant at that point because multicast operates at the network level and not on the device broadcast level. So we would always say, hey, if you want an out-of-the-box experience, we want you to use 22255. And the way that you think about that then is, okay, The first 24 bits in the IP range, okay, all of this, again, this is 22255. All of those are going to be the network identifier, and then that last set is going to be the actual, whoops, I did those colors backwards. Really sorry. I'll do this. So that last set is going to be the device identifier on my network. And that way, let's try and be consistent here, Knutson. So, and that way, we know that when we see an IP address that's set up this way, and we've set it up. So if I say 192.168.85, that is my NDI network. And so if I plug a computer into the network and I get issued an 85 address, I know I'm on the correct network for my NDI stuff. It's actually very convenient to troubleshoot and manage on the back end, because as production people being introduced to IP workflows, you're going to be managing the network in some fashion. And so let's make this simple for you. When you set up your custom IP range in your DHCP, make it unique. 192.168, pick a number between 1 and 200. 192.168.85, I know that is my range. And if I plug a device into a switch and I get an 85 address, I know I'm going to be able to see the NDI information on the network. That is the idea, at least, behind how to make this simple for you. Okay? Even the New Tech University stuff, which is a great course, by the way, taught by Kane Peterson, and it is worth the money to do if you're seriously getting into NDI. But even the New Tech course says, hey, look, if you want to do this simply, we recommend DHCP, and we recommend that you use a single subnet. And the single subnet looks like this. If you're talking to network people about this, like, hey, I'm not doing the network setup, but I need to be able to talk to my IT department about this. This is known as a slash or a WAC 24 network. Okay, a WAC 24 or WAC 24 network. Basically saying that it is a 22255, or it's written this way, where if you say, hey, I want my IP range to be 192.168.85, WAC 24, that's how you'd write it out. Hey, can you make me a VLAN that is this? You would write 192.168.85.1/24, and your network guys would know, okay, they want this to have a gateway of .1, and they want this to be a 22255 network. That's network admin talk. And they might question you, and they might say, why do you need 24? Like, can we make this can we give you a part of a network, or why is that required to be 24? Now, there are other combinations while we're talking about subnetting, for example, where you could do 255.255.255. What is it? Here. 190. Shoot, what is it? 128 plus 64 is a 192. That's what it is. So you could write it like this. What 192 is going to give you is it's going to give you less addresses. It's not going to give you 254 logical addresses. It's going to actually limit your addressing. So in the binary world, it's going to look like this. And what that does is actually limits you down to having only a certain amount of IP addresses in this specific range. But this will actually enable you to have multiple subnets. Okay, so when you write a subnet like this, what it does is it allows you to have a subnet, and you can break it up into, I believe it is 2 networks. I can't remember. I don't actually regularly do this. 2 or 3. What's the logical? We can find out. What is the logical network chunk? If we do, So if I just type that in here to the almighty Google, yoink, not HT, Chrome is trying to be too smart. Okay, here we go. So when we are talking about subnet masks and we say 192, that is a 6-bit, right? Because we've got 6 bits here on the end. So if we go back to our devices, we've got 6 bits here, which is our identifier, which means that we can have 64 addresses. Okay, so that breaks our network up into, what is that, 4? 4 segments, 64 times 4. Yes, 64 times 4 is 254, or 256. So this would give us 4 subnets in this configuration. And you can even do, and this is known as a WAC 2.6, by the way. This is a WAC 2.6 network. So this is where if you wanted to do actual subnetting and you wanted to have multiple subnets across the same NDI range, instead of doing VLANs, you could do subnets, and you could say, I want a WAC 2.6 subnet, and this would give you 4 subnets to work with. And then you could logically separate them by floor or by department or by switch or by something like that. So when you plug into a portion of your network, you would get a specific subnet address, which then you could tell, oh, I'm on floor 3, or I'm in the finance department, or I'm in the NDI network or the Dante network, or break it up logically over subnets. It actually does make it quite manageable in terms of now you can separate things over subnets. The difference is that now you're going to need to use something like Access Manager to allow cross-subnet traffic, because NDI is going to want to stay in its own lane on its own subnet. And so if you were to do something like this, you would need to then tell Access Manager, hey, I've got cameras on 3rd floor and I'm on 1st floor, and I need to be able to see the 3rd floor cameras. But this goes outside of, this is not a VLAN. This is a subnet separation, and that actually allows you to have a more manageable side of things on the IP level, where you can see the IP address that gets issued on the DHCP and know, hey, okay, I'm plugging into the switch on a finance port, or I'm plugging in on the 3rd floor, or I'm plugging in on the NDI network. Depending on how you break it up, the subnet can actually allow you to separate the data that way instead. So if we were to then just say, well, what do we need to do for NDI? And why was NDI developed this way? Well, the why I can't really answer. I don't really know why specifically we went with a 22255 network, because I wasn't there when it was invented. But it does appear that things are in the SDK, and the SDK is the piece of programming that NDI gives to everyone to develop their products. This is basically what the go-to is. Doesn't mean that it is the only way to do it, but this is kind of the default. If you were to take something out of the box and plug it in, NDI kind of expects that you to be running over a WAC 2.4 network. This can be changed, but does it need to be changed? Probably not, because this will do enough until you get to the next level of sophistication. And so I would advocate, from a out-of-the-box experience, if you're doing unicast, this needs to be your go-to. We don't need to overcomplicate things. We don't need it to be for you to have a humongous network for no apparent reason, because if you're going to have a humongous network, you need to be talking about a more sophisticated design, like multicast. One more thing I'll say about this. Some people say, well, I don't want to be limited to 254 IP addresses. Now, they say 256, but 2 of those addresses are reserved, and so you're going to only get 254 usable IP addresses on a 22255 network. But some guys will be like, well, I don't want to be limited, so I'm just going to do double 255. And what this will do is, remember what we were talking about earlier, this will mean that the identifier The network identifier is going to be this section, and the device identifier is going to be the back end. And we know in binary what this looks like, right? So we know that the first two. Oh, I'm sorry. That's it. That's not correct. Sorry. Because each of these are representing bits. So in each of these octet, there's 8 bits. And so what's happening is the network is going to be on one side, and the device identifier is going to be this giant conglomerate. But there's a major problem, is that devices, and specifically network nodes, are not able to catalog and literally get to all of these devices in the amount of time that it has to get across the wire. And so if we're doing a double 255 network, we're talking about 64,000 IP addresses. So when you go from a single 200, a single octet being the identifier, so a triple 255, we have 254 addresses. If you, and especially if you don't know what you're doing, if you just change it, instead of the network mask being triple 255, you go to double 255, these IP addresses is 64,000 IPs. Okay? And not IPS, that's Internet Service Provider. Ugh, I hate all these shorthand. 64,000 IP addresses. And you think, well, then I'll just never run out. The problem is that you won't be able to you actually, the devices themselves will not be able to navigate the network and communicate with those devices on the network. And so this is not a great idea. Doing a double 255 is not a great idea when we're talking about NDI networks. We need to be sticking to something that's manageable, not only for you, but also for the actual network nodes. The NDI SDK seems to be under some assumptions when it comes to networks. And the first is that your network is well aware of what it's doing. And that doesn't translate over to the Dante world. Because Dante actually has some things working behind the scenes that help it traffic the data. But Dante is also using very low amounts of bit rates, very low amounts of data when it's passing the audio channels. And so it's not requiring heavy loads of information to be passed quickly. It is purely just requiring that the low amounts of data get passed across the network, effectively and quickly. And so when we're talking about a few megs versus 100 or more megs, that's a lot more work to be processed. So with NDI, we need to be sure that we adhere to a specific set of networking rules just to make it make sense for the network nodes that are already on the network. So people get bent out of shape when we send them a list of network requirements that say, please set up your network this way. And then we get network admins that say, well, I know how to do networks, or I know I know what's best for my switches or my network. It's like, first of all, none of us have more than 5 years experience running NDI because it really hasn't been around that long. And hand on heart, we haven't done a very great job of telling you how to design a network for NDI. That works well with NDI. And so you've got all these guys that have been in the field since day one, and they genuinely have done trial and error over those years and have come up with their own bag of tricks that seems to work. But we really do recommend, and again, for the plug-and-play usability of the cameras, we really do recommend that you run it in DHCP, that you have a single subnet or a WAC24 network. So this is 22255, right? So we can say, let's see how we can write this. Okay, .0. So we have a DHCP network that's running a WAC24 network. That's going to give us 254 IP addresses. And that's going to be sufficient for a TCP or a RUDP network, okay? That will give you what you need. But the actual network management that's going on behind the scenes here is pretty important, which is why we say a DHCP. Now, if you want to run in static, you can. And I have been accused, and rightly so, in the past of saying don't do static. Because I know the type of tickets that it generates. You can run this in static, and wow, that was, oh no, sorry. Clicked a notification. Okay. You can run this in static. And I wrote that poorly. He chose poorly. Oh my gosh. Stinking Teams. It keeps taking up. Okay, let's just go down here. You can run your network in static. Absolutely. However, we do recommend that you're still running with a 22255, so a WAC24 network, which will give you 254 IP addresses. And I recommend that you actually, well, this is a better way to do this. I recommend that you run a discovery server. This needs to be on a Windows or Linux machine. And this IP address of this computer, which will be in static, is going to be your default gateway. So when you are on a BirdDog device, let's just say it's a camera, like a P200, inside the static information, you're going to set the IP address. You're going to set the subnet mask at WAC24, okay, 22255, and then your default gateway is going to be your discovery server IP address. In addition, you're going to turn on discovery server on the P200, and you're going to set that IP address to the DS computer IP. That is how that should function. And then once you do this, you're going to hit restart video. And when you hit restart video, you're going to watch the discovery server, which will be running on the computer that you got it running on. You're going to watch discovery server, and you're going to make sure that that source gets added to DS. If you do that, that should make things work fairly consistently. What DS is doing, and this is a great understanding as to how this all works. What Discovery Server does is when you turn Discovery Server on your P200 or your camera or whatever, it stops the broadcast requests, it stops the bonjour broadcasts, and it sends the broadcast directly to the IP address that you've indicated. It sends a broadcast request to that IP. When that broadcast, gets to that IP address, it gets logged inside Discovery Server, and Discovery Server then keeps an active list of all NDI devices on your network. Now, the cool thing about this is that it stops the broadcast requests, which means that your NDI devices will stop broadcasting. It also means that when you open Studio Monitor and you're not connected to Discovery Server, you will not see those sources. So it's a cool little way of quieting the network, of securing the network a little bit. It's not the greatest way to secure the network, but it helps a little bit because people can't peer in on your live streams, on your cameras and that sort of thing. But it also makes sure that your static network has somebody that is listening actively on the network. And so when you say, well, I want to run static because then I won't lose the IP addresses, all good. But for NDI, you're then going to be required to have a computer that's running Discovery Server. And that is then the logical way of setting up your IP addresses for your network, and more specifically, what it is that we're talking about when we are doing subnet masks. And where is it here? It's this one. This one here. The 22255. That is this one, this first, whoops, in binary, it's this one right here. That is the one, the way that your computer is going to be reading your IP information across the network. And that keeps it simple and keeps it consistent across all NDI installations, first of all. But I do believe that this is the baseline for how the IP structure was built and is expected to run for an NDI installation. All right, I'm sure that was mighty confusing. I have no doubt that it probably was. I'm happy to take some questions if you have any, but hopefully that gives you some insight as to why it's important we do the subnet mask information correctly and why we keep it down to a 22255, a WAC 2.4 network, why that's so vitally important. Okay. Hey, Network Chuck. Yeah. So if you want to learn more and you want it to be in a more coherent lesson, there are lots of dudes online on YouTube that can walk you through that. And I believe Network Chuck is one of those guys. My first P200 is 4 years old and wasn't my first NDI experience. I've learned more about NDI networking best practices here than in the entirety of the last 5 years. Wow. Jeez, man. That's 2 nice compliments from you guys in one day. That's unbelievable. Thanks, Angus. That's really helpful. I feel like I'm running, at least running towards the goal in the right direction. We run our Discovery server on a NUC. It saves us lots of hassle. You know what? I'm going to find out exactly who's commenting here because that's a great comment. Nicholas, that's awesome. Yes, Discovery server, by the way, pro tip, which I know is, this one's free of charge today. Discovery server can also run in a DHCP environment and actually works pretty well. So there you go. So if you have a DHCP, but you want to stop all the broadcast business requests on your DHCP network, Discovery server will do that. And yeah, it's good stuff. So I am worried now. I don't think our network is going to be amazing. We have been running 192.168 and static, and I think our network guy will be doing that again. Oh no. Well, we can certainly, walk through. Whoa, I got like a stray hair. What is going on there? Look at that. Or is that a mark on the wall or something? No. What is going on? Look at that. It's right here. I got it. Tuck that away. Yikes. I need a haircut, folks. So, Laura, we can talk about that because it depends on how he is managing that information. A double 255 is a very big network. And unless you're running this stuff on like a network that everyone's getting on, which you really shouldn't be, you should be isolating it to its own subnet or its own VLAN. You want to keep your NDI stuff separate and away from the other data that's happening on the wire. And so the first thing you could ask is like, hey, when you set this up, can you do a WAC 24 network on its own VLAN and just keep all my network stuff, all my NDI stuff in its own VLAN? He'd probably be like, yeah, no problem. Because VLANs are the next step in terms of security and isolation. They're the next step when it comes to how we've progressed. Subnets were kind of first. VLANs have been kind of the second thing. And honestly, VLANs are more secure than just subnetting things out. VLANs create boxes that you can put IP addresses in, and those IP addresses cannot get out of that box. Okay? It's like a vault. People are like, well, now I've got 3 VLANs that I want to see cameras on VLAN, 10 that are, in VLAN 4. That's kind of defeats the purpose of inter VLAN traffic. Is basically you're trying to do subnetting is what you're trying to do. But with VLANs as the way that they're kind of designed to be used, they keep your NDI traffic in its own lane, and they don't let packets interact with other VLAN packets. Okay? So that's the beautiful thing, is that then your wireless community is on one VLAN, and your finance department's on another VLAN, and your, whatever, you can break it out that way. And then those people are basically just limited to interacting with those devices on that VLAN. So when we're talking about NDI and we're talking about cameras, like cameras and video, and like these cameras can be used for crowd shots and for hallways and for, you know, all sorts of various reasons. Well, you don't want everybody having access to that. If they just open Studio Monitor, they can see all of your feeds. Not only is that a security issue, but it's also going to be pulling down large amounts of data to those devices. So to wrangle it a bit, you can put it in its own VLAN and keep it away from the general public, and then that's a helpful way to manage that data. It's on its own network other than a little Dante and TriCaster and 2 computers. So yeah, so just ask him to do a WAC 2.4 instead of he's probably doing a WAC 16, which is in the subnetting world. WAC 16 is that 64,000 IP addresses. So just say, hey, when you make the new IP network for our NDI stuff, can you just do a WAC 24? He'll know. If he says, what's a WAC 24, then you need to hire a new network guy. You need to give him a look like, oh, you don't know what that is? Say a single 22255 subnet. But he should know what a /24 or a WAC 24 network is. Some people use different terminology. Why is Discovery Server required when running static but not when running DHCP? What does DHCP provide that static doesn't? Oh, Daniel, great question. So, also known as a Class C subnet. Yeah. NetHab, get out of here. If you want to get technical. I'm just trying to make this accessible for people, right? But also understand its gravity and importance. Daniel asks, why is Discovery Server required when it's not for DHCP? Well, DHCP is actually doing the things that static networks are not. And when we say static, we basically mean anything that isn't running DHCP. So some people's static networks are doing some things and some people's are not. In particular, DHCP networks, DHCP services will delegate who is in charge of the routing table on the network. And so when you have layer 2 and layer 3 switches, managed switches, inside these switches, there is something known as a routing table. And sophisticated networks, ones that are worth their salt, are going to do something called routing table delegation, meaning that the network is going to figure out who is kind of the top chain switch and who should hold the master list, the routing list. And then the DHCP is going to tell the other layer 3, layer 2 switches on the network, managed switches, reference this master routing list. And so when a broadcast request goes out, the switch can then reference the routing list and figure out quickly what is the fastest path to that device that's being requested through the broadcast packet. When we run static networks, none of that stuff exists. And so nobody knows who each other is on the network, and every broadcast has to be logically mapped out, which means that those devices on the network all have to respond and say, not me. Actually, it's not entirely true. The broadcast request has to make it to that end point, all of them, okay, because it has to figure out who's who, has to make it to all of your devices. And when the packet gets to the device that is not the one it's looking for, the device destroys that broadcast packet that it's received, okay? It actually destroys the packet because it doesn't apply to it, except for that one device on the network that it is for. And then that device responds and says, hey, that's me. Well, that packet, that hey, that's me packet, goes back to everybody. And so now all of those devices receive that thing. And if it's not for that device, it has to destroy that packet. Work. Why? Why make this so much harder than it needs to be? I don't have anyways. There's an office quote in there somewhere. Why does it need to be this way? When we could put a device on there that stops the broadcast requests, catalogs all of the destinations and receivers and decoders, and knows all that information in a centralized location. That's what Discovery Server is doing. You can do it with DHCP, and it stops those broadcast requests, but there are mechanisms on a DHCP network within the switches and within the DHCP service that actually help route the data out single ports. But again, let me open up this again. A stupid, dumb network. Good, this is live again. All right, let's talk a little bit then about Discovery Server. This one's for free, folks. You're getting a freebie now. I'll try and make this as logical and concise as possible. But, oh, whoopsie daisy. Let's turn this off. Let's select this one. Okay, here is this. So let's say we have two unmanaged switches, right? And they're connected together via Ethernet. That's supposed to be an E. All right, and then we've got devices that are connected to, let's just say these are like 8-port unmanaged switches. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, these devices are plugged into the first 4 ports. And same thing over here. 4, 5, 6, 7, 8. And we've got some devices over here. And 1, 2, 3, 4. Okay. We've got let's say we've got a single subnet, and we're set up correctly, but we're running in static, and we don't have a DS. So we've got, let's say, .10, .11, .12, .13, whoops, .14, .15, .16, and .17. Okay. On this layout, and we've got a decoder at 17. I got a flex out. And I want to connect flex out to camera 1, which is on 11. Okay, camera 1 is on .11. We send out a thing and we say, hey, who's .11? Broadcast request goes out. Okay. But because we are stupid unmanaged switches, that broadcast request goes up my little Ethernet cable and it goes here. And this unmanaged switch does not know, oh, by the way, whoops. So we're coming out of port 8 here, and we are plugged into port 8 over here, okay? This broadcast request has to go up the Ethernet port and go into this little port right here, but then it's going to be basically sent out every single port on the network. So it's going to go out here. Whoops, I just erased a bunch of stuff, of course. Let's go back. Let's undo that. All right, so then it's going to go out here and here and here, but it's also going to go out here and then here and here and here and here. All of the places it went to, other than .11, will basically have to receive that packet, read that packet, and destroy that packet. When it gets to 11, 11 says, hey, that's me. I'm .11. And so it says, you found me. Yay. I'm .11. And it goes back to here. And these stupid switches will say, all right, number 11 is here, everybody. It's here, it's here, it's here, it's here, it's here. And all of these devices on this network will need to say, this isn't for me, and they'll destroy that packet. More processing, more work, more packets being figured out. And then 17 will say, great, here's the information that I want you to start decoding. And it will start sending that data then over to .11. Lots of work being done. This is all in assumption that this is the only thing being done on this network. But instead, if we've got other encoders or decoders, they're all going to be doing this all the time to each other constantly. So we get broadcast flooding, we get packet flooding. So when we put a DS on here, let's make this a new fun color. DS is going to be blue. Now we're going to introduce a discovery server. Instead of the broadcast bonjour packets going out, that is no longer happening. Yoink. Okay. Now we're going to have to redo some of this stuff. That's all good. Yoink. Okay. Now we'll plug in our devices again to each of our respective ports. We'll make an Ethernet connection. But we're going to plug in our discovery server into like one of these ports. Now DS has been activated, and we're going to fix our network here because I kind of screwed it up a bit. Okay. And we're going to plug our devices in. 1, 2, 3. Better invent that port again. 4. And all of these devices are going to be saying, hey, I'm a flex out. hey, I'm a P200. Hey, I'm a P4K. Hey, I'm a mini. Okay. And they're going to be telling this all to DS. And DS is going to be like, great, you're a destination. So we're going to have 2 destinations. And we're going to have 2 sources. So now, when our destinations say, hey, we want to decode the P200, it will say, oh, that is over on dot 11. And so we need to communicate directly with dot 11. He can be found this way. And that packet will then be sent to the unit that is registered as dot 11. And so we stop that broadcast nonsense that's going to all of these different devices. And instead, DS will say, hey, dot 11, flex out, which is that dot 17 wants to decode your source, and we'll make that logical connection on the network side. Now, again, the statics, the unmanaged switches are unhelpful, because unmanaged switches basically, now you're going to get mad at me. Network guys get mad because I interchange these terms, and they are different. Unmanaged switches are essentially hubs. They are not literally hubs, but they are essentially hubs. And what hubs do is they don't care who's who and what's plugged into what. They just turn the packets around and send them out the ports and say, this is for somebody. And they send the packets down every port, and it's up to the device to either accept or destroy that packet. That's essentially what unmanaged switches are, okay? And that term, they don't use the term hub anymore. You can technically still buy hubs in the world, but they don't use the term hub. But that term hub basically got swapped out for the term unmanaged. And if you're doing any level of sophisticated network routing or anything like that, you need to get away from this unmanaged switch realm. A managed switch usually has, I'm usually trustworthy, name that movie. A managed switch will have the ability to learn what is happening on the network and what devices are plugged into which ports, physical ports on the switch. So then when the flex out says, hey, I want to decode the P200, the DS can say, okay, you want to decode P200? Well, dot 17 is on port 4 of this switch, which is like dot 21, and this switch is dot 20. So the pathway to get to the P200 is going to be through this port, it's going to be from dot 17 through dot 21 over to dot 20 and then out port 2 on that switch. And that is going to be dot 11. So it knows to send the packet through that chain to get through that, to get over to that device. And it quiets, it makes things a lot more efficient, a lot more powerful, a lot less busy. Okay, it cleans things up substantially. So DS on a network is super helpful, whether you're using, well, for sure if you're doing static, but if you're doing a DHCP, it will stop the broadcast requests and will make it less important that the routing tables stay relevant all the time. So that's a long-winded answer as to why it is advantageous to use a DS in a static environment, just because it adds a level of intelligence that you don't know you're missing until it's missing. If he's old, he may know them as a term class C. Touche, NetHab, touche. LA12 live streams. What's going on? I don't recognize your username. So welcome. If you're new, thanks for stopping by. Hey, I spoke to the sales. I pre-ordered an X120 from. Seems that they were guessing on the dates and to get the pre-orders as in the 19th of May. They now say delayed, as is not even shipping, and then as yet ordered, canceled. You canceled the order? I know they're making it. I know that the X120 is coming out, but I do not know what the launch date is. If you know something, please let me know, because I haven't heard. It's actually, we're coming up on a deadline over from NAB, and so I'm sure that we'll be having an announcement about that, whether it's ready or not. We need to keep our customers informed. So, is the default gateway of the camera really the DS server? Should it not be the router on the local segment? Otherwise, the DS box would be routing IP traffic between segments. Okay, so this is one of those things that I did not clarify. This is assuming that you don't have a gateway, okay? Because I've had guys install as they say, well, I've got a static network, no router. Everything's just set to static. I just keep it simple. Set it to static. I'm like, oh, you don't know what you're saying. Not in the NDI world. So if you don't have a gateway, then you point the gateway at the computer IP address. If you do have a gateway, then yes, please use the gateway address. Absolutely. Matthew, good point. And hey, welcome to the show. I appreciate you dropping a comment. So I haven't been on in a while, but I'm just curious on how the tests went with Dante and NDI on the same VLANs. Are there any issues to be aware of? None that I have discovered so far. I haven't done a rigorous test, though, truth be told. But let me talk to Jake, because he has multiple configurations, and he might be able to shed some light on that. And another question. I envisioned you saying that very snippy. I'm just kidding. What's going on, Alex? Good to see you again. Any tips on setting up a multi-port NIC on a PC so all ports work with the same VLAN for NDI? Yes. Depending on the switch that you're running, I'm doing that actually. So I changed my network configuration with my 2 fiber ports that are plugged into this VLAN because I was having issues running all this NDI stuff over 1 gig. I just plugged them both into the same, and I took I took all the customization stuff off. And because my NIC cards each have individual MAC addresses, they linked up no problem, and I'm not having any issues with it. So you can, especially if you're running a 4250, it appears to me that if you have a NIC that has 2 individual MAC addresses, it's not the same MAC address. If you're running a NIC device that has been made in the last 15 years, then you probably be pretty fine plugging them both into the same network. Now be careful, because you might create a loop, and that might screw with things. But you shouldn't, because normally cards that have multiple network connections are all giving out individual MAC addresses, and if that's the case, then you should be good. You should be good. But please test. Don't take my word for it, like LeVar Burton on Reading Rainbow, but don't take my word for it. Clients still need to ARP for the IP of DS. This broadcast behavior is same for managed unmanaged switches. Both have CAM tables and learn MACs on ports. Sorry, I read that too fast. Hang on. The clients still need to ARP for the IPs of the discovery server. This broadcast behavior is the same for managed and unmanaged switches. Both have CAM tables to learn MACs on ports. Here's the thing, though, is that the network nodes, which is what NDI devices that are running the SDK for NDI, the devices do not learn who each other are on the network, including decoders. Decoders ping for a list, and that's it. So that's why when you're running a static network and you hit refresh on that list and you get a partial list, that's because not all devices are broadcasting at that moment. But they do not compile a list, which means that if you hit refresh again, that list will update and change. But it won't remember. So there's no onboard memory that's learning what MAC addresses are associated with which IP addresses. They're just network nodes. So you need a discovery server on the network to learn, especially if you're running static, to learn who's who and to keep an active list of MAC addresses to IP addresses and what their function is in the NDI realm. So it's just a network node. They're not computers. They're not learning anything. They're just reading the data as it is presented in that moment. That's all they're doing. Same thing with cameras. They're just generating NDI. They're not learning anything. They're not interacting with the network. They don't care who else is on the network. They do not care. It's up to the network to know what is going on. And that is the major misconception, is they're like, well, they're like little computers. No, they are not. They're cameras. They're nodes on a network. They're not interacting with the network at all. They do not care, which is why when you set an IP address and you fat finger the default gateway, that thing's gone, and it will not learn, and it will not do anything other than it was told to do. So you have to be super careful when you're interacting with the IP information on these devices, because if you do it wrong, they will do what they are told, and they will be gone, which means then you've got to either nuke it with Neuralizer, or you've got to get it over to Bird Dog support, or you've got to re-image the camera. It gets worse and worse the more customization you get, which is why I always am like, don't overcomplicate. If you don't have to overcomplicate it, don't do it. Run a DHCP. Run a WAC24 network or a Class C network. Run a simplified network with a proper router and it on its own VLAN maybe. Make it easy for yourself. Run it in DHCP with a DHCP reservation list if you absolutely don't want the IP addresses changing for some reason. If your network is notorious for handing out multiple IP addresses, which I'm not too sure. But make it easy. And you hate to say it, but be willing to learn. Not to anybody here, by the way, but like I get integrators that are like, no, it's, if it's not going to work the way that I designed it, then I'm not going to use it. It's like, just be willing to bend a little bit, because I think actually you'll love the benefits of NDI, but you 100% need to adhere to kind of the expectations of the NDI network. And shame on us for not saying what those expectations are clearer earlier on in the game. I am saying it now, by the way, because the people that were holding the line to make sure that we don't say something about network are gone. And so now I'm just saying it loud and clear. If you're looking for a plug-and-play option for your clients, DHCP, WAC24 network, have a default gateway. Run a DS if you want in this configuration, but be sure that if you need to know what the IP addresses are, you don't want them changing, find out what the DHCP reservation list is and go with that configuration. If you're doing more than 100 devices, honestly, if you're doing more than 20 NDI devices, and in particular decoders, then you need to be talking multicast, and this conversation is kind of besides the point. All right, let's get back to this all this conversations here that we're having. Has it been 6 weeks since NDB yet? This is week 6 right now. This is technically middle of, this is what is the end of week 6 or the beginning of week 6. How to use NDI HX3 on BirdDog Play. It should auto-detect HX, so you can just send it a HX signal and it should pick that up. Any HX signal I've sent, it just sees it right away and lists it as HX on the dashboard. I wish it would say HX3, but I don't actually think there's an identifier that specifies in the protocol. What do you mean take off the customization from the card of the M4250? Are 4 ports the same as 2? Oh, no. So, sorry. I was lagging my ports, so I was doing like some specific stuff with mine and getting all fancy with the settings. And I took off the lag, and I took off all my custom settings on the NIC card. I'm sorry, on the actual NIC itself, and just plugged them in. And I got 2 IP addresses on 2 MAC addresses, and I'm good to go. So seems to be balancing. Now, here's a cool thing about NDI. Maybe you don't know. NDI load when it has 2 connections or more to the network, NDI itself will load balance. Now, it will load balance sources entirety. It won't load balance bit rates. Like it won't say, okay, you have half a gig of data, so I'm going to put a quarter of a gig over here and a quarter of a gig over there. What it does is it says you've got 3 sources, so I'm going to put 2 sources here and 1 source here. And when you turn on another source, it'll say, okay, I'm going to put that on the one that only has 1 source. So it tries to load balance a little bit so that it uses the resources more widely that's at its disposal. And that's written into the SDK on the receiving side, which is really cool. So kudos to you, NDI. That's a really neat idea that seems to be working. I mean, I'm watching it in real time right now, and I'm definitely seeing the benefits of having 2 gigs into my computer and not 1. MDNS, bonjour, behaves similarly to ARP, but doesn't get cached by the switch. So there's 2 sets of broadcast responses for each and every devices. I need to get a network course stat. Hey, if you want to take a network course, then, hey, thanks. I'll be back in a week if it doesn't work. All good. It'd be a pleasure to have you back on, Alex. If you actually are interested in learning more and doing self-paced, man, I cannot say enough about the options that are out there for Network Plus. Some people are like, oh, you should do CCNA or you should do yada, yada. If you want a great general understanding of networking and you're not going to do it for a living, take the Network Plus course. There are multiple offerings out there. Look around. I took one that was over on udemy.com. It was really good. I've recommended it to multiple people. It is a little bit of money. It's like $20 when it's on sale, but it's 80 hours or something like that. I forget how many hours of video it is. It's a ridiculous amount. And he has little quizzes and things to make sure that you understand concepts. But seriously, take the Network Plus course. It was recommended to me years and years and years ago by somebody, and it is a great little brush up on understanding concepts of networking. And so by all means, if you're serious about that statement, Laura, go home and look up Network Plus on YouTube, and you'll find a whole bunch of stuff on there for free. But if you really want a whole course that would prep you for like certification, then, there are official options out there. Guys that actually go through the coursework and then will prepare you for certification. So yeah, check that out. The CompTIA Network Plus certification preparation course is great. Yeah, good stuff. And then, you can help the networking guy if he runs into issues. Okay, folks. Well, this show was not supposed to go this long, but it totally did. And man, I am actually exhausted. Tired of talking. And you're probably tired of listening. I didn't think it was going to go an hour and a half or an hour and a quarter. So, hey, thanks everybody. That's impressive. We're approaching the officially 2 hours of being on air. But hopefully you found some of this beneficial, not super confusing. And here's the thing about networks is they're unique to the person who designed them. And one guy is going to think that he knows best, and the other guy is going to think he knows best, and they're going to design their networks individually and uniquely and all of that stuff. And so, there are multiple ways of getting to the finish line. Doesn't necessarily mean my way is the highway, and it doesn't mean your way is the highway, but we need to be sure to do effective NDI networking. And from what I've seen, this is kind of the way that the protocol is mapped out. Again, doesn't mean it's the only way to be done, but it definitely is a way to get it done. And I cannot speak highly enough. I genuinely think Discovery Server was meant for every single NDI installation, but it was one of those things where we didn't want to tell people how to design their networks. And I say we as in the NDI community, not BirdDog exclusively, but the NDI community was so anti-explaining how to do this that we forgot to tell people how great Discovery Server is. And I genuinely believe that Discovery Server was supposed to be a part of your NDI install. So if you're looking for consistency, if you're looking for a way to quiet down the network a little bit, to gain a little bit of performance, you might look at Discovery Server as an option, but it does need to run full time. It does need to run full time. So take that into consideration and as a caveat. All right, folks, I'm going to let you go. Man, I have really enjoyed being able to hang out with you guys today, Tuesday. This has been a good one. We're going to do it again, though, on Thursday. So if you haven't done so already, please jump over to birddogjohn.tv and subscribe to that show. You don't have to hit the bell. You don't have to. But it's actually super handy when I go live. You get a notification on your phone or whatever, and you can join us. So birddogjohn.tv, that's where we hang out. Every time I do something on this show, it gets broadcasted to that channel. So please join me over there. Subscribe to that show. It's a great way for me to show my bosses that I have a following and that people are interested in what it is that I'm doing. It's really helpful. So if you wouldn't mind, hit me up there. Of course, if you have a question between now and Thursday at 11 o'clock Eastern time, don't forget to chat with my guys over at help@birddog.tv. Got a couple of agents this week that are working full time, and they're making that happen. And so be sure that you open a ticket with us. We promise we're going to try and get back to you as best we can. But this show and that email address is the number one way to get a hold of BirdDog support. You can go on Facebook and talk to the greater user community. You can go on Reddit and chat with the strangers that are on there, or you can come right to the support department, help@birddog.tv, or right here from 11 to at least 12 o'clock Eastern time for more than 60 minutes a day on Tuesday, Thursdays, twice a week, right here on birddogjohn.tv. So be sure that you join us. Be sure that you join our community. I love having you guys hanging out with me and chatting with me. It's always a good time. And I hope that we learn something from each other. So I always learn something when I hang out with you guys. And I hope that you guys can take something away from today. Even if it's just, I'm doing it right. I think I'm doing it according to how BirdDog sees it done. Or, hey, maybe I'll try this alteration, see if that increases performance. All good. And bring those findings back to the show. Because I want to actually hear from you what your real experiences are. Special shout out to Laura. We got to hang out and see her behind the scenes tour, and I'm really excited to see what changes you're going to make so we can compare and contrast that video with whatever else you got coming up And it's always great to have you here from Western Canada. So really cool stuff. It is a beautiful day over here in Auburn Hills. Sun is shining. It's about 70, what do we got here? It's 73 degrees outside right now. So it might be a great day to take a walk and have a little gander outside. What's good for the goose is good for the gander, right? So there are lots of geese outside. So maybe, and I'm the gander. It's an IT crowd quote. Anyway, so be sure that you hang out with us on Thursday. I would love for you to come back. Please make an effort to join us if you can, and join me over there on birddogjohn.tv. Hopefully you're doing well. Take care of yourselves, folks. It's always a pleasure to be with you, and I hope you'll come back. But in the meantime, take care of yourselves. Take care of each other. Super important these days because there's really not enough of that going on. And we'll see you in a couple of days on Thursday. That's the plan at 11 o'clock Eastern Time right here on birddogjohn.tv. Take care, guys. It's been a blast. Bye.
Perhaps you think you're being treated unfairly.